Physics Part 385. The Geiger counter. Figure illustrates a Geiger-Müller tube with a scalar connected to it. When radiation enters the window, it creates ions pairs in the gas in the tube. These charged particles, and particularly the electrons, are accelerated by the potential difference between the central wire anode and the cylindrical cathode. These accelerated particles then cause further ionization. The result of this continuous process is described as a Valence effect. That is, the entry of one particle into the tube and the production of one ion pair results in very large number of electrons and ions arriving at the anode and cathode respectively. This gives a pulse of charge which is amplified and counted by the scalars or rate meters. A scalar measures the total count of the pulses in the tube during the time, and the scalar is during the time the scalar is operating. A rate meter continuously monitors the number of counts per second. Once the pulse has been registered, the charges are removed from the gas in readiness for further radiation entering the tube. We call it Geiger-Müller tube and scalar. We've got a thin mica window, we've got a positive wire anode, we've got scalar or rate meter, we've got argon gas at low pressure, we've got negative cylindrical cathode, and that's in fact composes the Geiger-Müller tube and scalar. Photographic plates. When a radioactive emission strikes a photographic film, the film reacts if it had exposed to a small amount of visible light. When the film is developed, fogging or blackening is seen. This fogging can be used to detect not only the presence of radioactivity, but also the intensity of the radiation. The figure shows a film badge dosimeter. It contains a piece of a photographic film which becomes fogged when exposed to radiation. Workers who are at risk from radiation wear such badges to gauge the type and dose of the radiation to which they have been exposed. The radiation passes through different filters before reaching the film. Consequently, the type of radiation as well as the quantity can be assessed. Well, the scintillation counter. Early workers with radioactive materials used gloss screens coated with zinc sulfide to detect radiation. When radiation is incident on the zinc sulfide, it emits a tiny pulse of light called scintillation. The rate at which these pulses are emitted indicates the intensity of the radiation. The early researchers worked in darkened rooms, observing the zinc sulfide screen by eye through a microscope and counting the number of flashes of light occurring in a certain time. Now, a scintillation counter is used in the figure, and we find a scintillation counter. We've got radiation photon, we've got photocathode, we've got photo multiplier, we've got photo electrons, we've got crystals, and that's what the figure is all about. Often often a scintillator crystal is used instead of a zinc sulfide screen. The crystal is mounted close to the device known as photomultiplier, a vacuum tube device which uses the principle of photoelectric emissions. Flashes of light cause emissions of the photoelectrons from the negative electrode of the photomultiplier. The photoelectric current is amplified inside the tube. The output electrode is connected to a scalar rate meter as with the Geiger-Müller tube.